no, maybe it was arc length that we did. Did we not do? I don't know. I don't remember. Anyway, not important. Here we go. So we want to be able to calculate the area. Yesterday we did areas of plane figures. And a circle, the area of a circle is pi times radius squared. That's the area of an entire circle, but what we're looking at today are just sectors of circles, not all the area. We want just a little fraction of the area. A sector is a section of a circle bounded by a central angle. And a central angle, if you remember, goes through the center of the circle. So we have this nice little central angle. And maybe, and it's intercepted arc. And so it's got its little intercepted arc that it eats. Think of a sector like a slice of pizza. Fun. Okay. The area of a sector of a shaded region is a portion, or rather the word be fraction, a fraction of the entire area. So it's just a fraction. So the area of a sector is simply a fraction of means multiply, and pi r squared gives us the area. So the fraction is, we're going to have some fraction. Well, if I know that my little central angle has x degrees, that's x degrees out of how many degrees in a circle? How many degrees in a circle? 360, yep. So this is x degrees over 360 degrees. See how the degrees match? All right, so this is a fraction out of 360 degrees. So how many we want out of the total 360 degrees? And that'll give us our area of a sector pretty easily. So let's look. We want to find the area of each shaded sector, round to the nearest hundredth. So let's look at number 2 here. The area of the sector is what fraction? 139 out of 360 times pi times the radius, 22 squared. Can you put that in your calculator? Like, do I need to do it, or can you do it? No, I mean like you can, like, you know how to do it?
Yeah.
Yeah, probably?
Yeah.
All right, good, because that's, that's just calculator math, right? So, all right, let's move on. Let's look at number 4. This 126-degree angle is not the shaded area. So how do we figure out the shaded central? Yeah, all right. So minus from 360. So let's see. So 360 minus the 126, and what do we get? 234 degrees. And so if we want to find the area of the shaded region, it's going to be what fraction? Yep, 234 out of 360 times the area. Pi times radius, 13 squared. You good with that? Yeah? You're good with that, right? Yeah? Okay, perfect. Let's turn the page. Oh, you wanted to be done? Okay. Not too much here. All right, what about number 8 here? Yeah, 360 minus 90. So again, to get that shaded side, which is what we're interested in, 360 minus 90, which is 270 degrees. So the area of the shaded region would be 270 out of 360, which is, that reduces, do you know what that reduces to? 3/4. Yes, it is 3/4. This is 1/4. This would be 3/4. So, okay. Pi times our radius, which is 29.5 squared. Okay, good question so far?
Yeah.
All right. Let's look at number 12. Find the total area of the shaded region. So here we have a couple of shaded area regions. Tell me what you think we should do here. Interesting. Yeah. So both, how do we know that the other side is also 113?
The one that starts with a V.
Vertical angles? Yes, those are vertical angles. Okay. And so if we want the total shaded area, then the area of the shaded region would be how many degrees? 226. 226, adding up the 113 and 113. So 226 out of 360 degrees, that's what we want, times pi. XY, XY is a diameter, so we need a radius of 15. So be careful, this was a diameter. So watch out for that trickiness. That's a diameter. We want to divide that by 2. All right. What about number 13? Let's think a little more. Number 13. We can, yes, you can do that. So we know that the other side of this is also 143. And then, so we'd have to subtract both of those from 360. Could you also figure out what this little angle is? From 180. Yeah, we have a nice straight angle there. So we got 180 degrees. So I'm going to do it that way. 180 minus 143, which is 37?
Yep.
All right. Which means both of these shaded areas are 37 degrees. So lots of ways to figure that out. What is that, 60, 74 degrees? So the area of the shaded stuff is 74 degrees. 74 degrees out of the total 360 is shaded. And we want pi times radius. EB is a radius, so 10.4 squared. All right. Cool, let's just do one more. How about number 16? Triple 62, because all of these are 62. Very good. We know that they've got congruent intercepted arcs, so the central angles are also congruent. Okay. So, and then we want to subtract that from 360? Okay. And so if we did that, I don't know what, 62, 186? All right, so 360 minus 186 is 174 degrees, must be shaded. So, all right. So then our area of our shaded region is 174 out of 360 degrees times pi times our radius is PC radius, yes, of 12 squared.
Yes.
Yeah?
Yes.
Good?
Yes.
Should we keep going?
No.
Okay. Happy Friday. Hey, 9 minutes.